Hi, hello everybody. So this is the video dealing with section 22, complex numbers. And again, on this topic, I will have two videos. The first video is going to be an introduction and where we cover the operations of addition and subtraction, evaluation, and multiplication. The second video is going to be dealing exclusively with division, which is a little bit more complicated. All right. So the idea of complex numbers come up from the following problem. Now, this is the standard problem, x squared minus 1 equals 0. And when we solve it by difference of squares, we factor that. We get x minus 1, x plus 1. Apply the zero property rule, and we solve each term. And we get either x equals 1 or x equals negative 1. We've done this before, nothing new. Both of these answers satisfy the original equation. So if you replace x with either 1 or negative 1, when we square it, we get 1, 1 minus 1, 0. So that's okay. So here's the problem when we change the equation from x squared minus 1 equals 0 to x squared plus 1 equals 0. Now, so problem number 1 is x squared plus 1 is not difference of squares, it's not factorable, so we can't factor. So we apply the square root property, meaning we first subtract 1 from both sides, and then we take the square root of both sides. And on the left, we get x. On the right, we get plus or minus square root of negative 1. The problem is the square root of negative 1 is not a real number. So if you try this on the calculator is going to say error. So in mathematics, we have the situation now that anything dealing with the square root of a negative number is not a real number. So how do we handle that? So the idea of complex numbers came about from this very equation right here. So from now on, the square root of negative 1 is going to be defined as I. Or more importantly for us, I square is going to be minus 1. So anytime we see a minus 1 inside of the radical, we will have to make the substitution in order for the problem to be solvable in mathematical terms, okay? So this quantity, I square equals negative 1, is what makes complex numbers possible. And so we're going to be doing some of these problems. For example, before we even go into addition and subtraction, multiplication, let's take a look at evaluating the following. Take a look at these examples, A, B, C, and D, square root of negative 9, square root of negative 25, square root of negative 7, and negative 8. None of these values, if you do it on the calculator, you will get a real value. They don't exist as real numbers. So what do we do? So instead of working with the minus 9 under the square root, we're going to introduce the concept of that minus 1 is I squared. So look what we do. We rewrite square root of negative 9 as 9 times negative 1. The negative 1 is I squared. Okay? Or the square root of negative 1 is just I. So we can now simplify the square root of 9 as 3 and the square root of negative 1 as I. So the original problem, which was not possible in real format or as a real number, became 3i, where I is what we call an imaginary number. The same thing is going to be done with the square root of negative 25. So we rewrite it as square root of 25 times minus 1. The square root of 25 we know to be 5. The square root of negative 1 we know to be I. Okay? And similarly for square root of negative 7. In this case, square root of 7 cannot be simplified further. So this will be square root of 7i. In the case of minus 8, we break 8 as 4 times 2 because 4 is a perfect square. We can simplify 4. So square root of 4 is 2. Square root of 2 is just square root of 2. And square root of negative 1 is just I. So this is what we have to do when we're simplifying these radicals that are square roots and have a minus inside. They just don't work as real numbers, so we change them to imaginary numbers. Okay, so formally, a complex number may have a real part, which is A, and it may have an imaginary part, which is B. So we are always going to write it in the form A plus BI, where A and B are any real numbers. Okay? When we are doing addition and subtraction, the I just behaves as a regular variable. Just if I had, for example, 2 minus 3x plus minus 7 plus 4x. We combine like terms. So the 2 and minus 7 go together to give you a minus 5. And the minus 3i plus 4i get combined to give you a positive 1i or just I. So the final answer will be, as you see here, minus 5 plus I or 1i. So it's very easy, right? Addition and subtraction. This is a case where we have subtraction. So again, 9i and 16i are paired up as like terms. So I have 7 minus 3, which is 4, and 9i minus 16i, which is minus 7i. So addition and subtraction, extremely easy, should not be a problem. When we have multiplication, we'll do some of these problems in a few minutes. When we have multiplication, it's the same thing as before. The I behaves as if we had just an X. So this is going to be done exactly the same way as if you had 2 minus 6x, 7 plus 3x. We have to FOIL, right? So we'll do 2 times 7, 2 times 3i, as you see over here. And minus 6i times 7, minus 6i times 3i. So here on the second line under the solution, you have 2 times 7, 14, 2 times 3i, 6i, minus 6i times 7, minus 42i. And the last one is the most important multiplication, because just like if I had 6x and 3x, I would get 18x squared. In here, I'm getting the minus 18i squared. And here is the issue that you have to remember when you're doing complex numbers. You're going to combine like terms as before, right? The 6i and the minus 42i will give you minus 36i. But the I squared now has to be replaced back with -1, because that's what it is. So remember from the definition, going up here, I squared equals -1. Anytime inside a problem dealing with complex numbers, addition, subtraction, multiplication, or division, if you get an I square, as you do here, that must be replaced with the -1. So now look what happens. So I'll have the minus 18 times -1, which is positive 18. And now the positive 18 gets added to positive 14, which is 32. So the final answer would be 32 minus 36x. Okay, so multiplication and division, this is going to happen. I'm going to show you when we do the division problems. So let's take a look at the problems I selected for us to do. And we'll do a couple, dealing with simplification. We'll do a couple dealing with addition and subtraction, and we'll do maybe 1 or 2 dealing with multiplication. All right, so -49. We can't do this on the calculator. It's not possible, as I said. So I am going to rewrite it as 49 times -1, which I am now can do this. Radical 49 times radical -1. This I know to be 7. This I know to be I. So 7i is the answer. Very, very easy. Same thing with the -90. It's not a real number, so I'm going to write it as 90 times -1. The 90, I cannot take the square root of 90, but I can break it as a product of 2, which is 99 times 10. And here's my radical -1. I know what this is. This is 3. The square root of 10 I cannot simplify, and the square root of -1 is just I. So the final answer for this is 3 radical 10I. Okay, so these problems are very, very easy to do. Should not be a problem for anybody. How about these two, addition and subtraction? So same as before, right? 4 minus 12 minus I plus 14I, just as if I had x plus minus x plus 14x. So this is plus 13I. Now, so remember, right, just like with the x, if I had something like this, right, there's an invisible 1 in front of the x, so you combine, you do the operation on the coefficient, so 14 minus 1, 13x. Same thing here. 22.9 minus 22. Be very careful. Minus a minus, right? It's positive. So I have minus 22 plus 17. Right? Minus 5. And I have minus 13i minus times the plus is minus, so minus 8i. Minus 13i minus 8 minus 21i. Notice that they stay I, just as if I had minus 13x minus 8x. This is just minus 21x. We're not multiplying here. Okay. And now we have a couple of problems dealing with multiplication. And I'm going to do 22.14 first because that's the easiest one. So this is identical to doing something like this. Okay. I is just a variable. So I times 5, we just write the number first, 5i. And minus, there's an invisible 1 here. So this is minus 6i squared, right? I times I, just like x times x is x squared. But now be careful. Whenever you see an I square, you have to make this substitution. Is mandatory. So this will be 5i minus 6 times minus 1. So this is obviously positive 6. And we really don't leave it this way. We always write the number first and the imaginary part second. So we leave it as 6 plus 5i. All right. 2213, this is the case where I have to FOIL just as before. So we'll do 3 times 2, 6. 3 times 3i, 9i. Negative 4i times 2, negative 8i. And negative 4i times 3i is negative 12i square, right? Just as if I had 4x times 3x. Combine like terms. So this is 6 plus 1i, or just I, minus 12, but here is the I square again, and you have to make the substitution. Minus 1. So this is positive 12, so I have 6 plus 12 plus I, which is 18 plus I. Okay, so whenever you see I square, you make the substitution. Let's take a look at the last two problems. We'll do this one first because it's the same type of foiling, but something special is going to happen here. So 3 times 3, 9. 3 times 2i, 6i, negative 2i times 3, negative 6i, and negative 2i times positive 2i is minus 4i squared. Look what happens here. Positive 6i and negative 6i both cancel. I'm left with 9 minus 4i squared. And again, I see I squared. I have to make the substitution. So this is going to be 9 minus 4 times minus 1. 9 plus 4, which is 13. Okay. The last case, if I only see one term with the square here, how do we do this? Well, you double up, right? 5 plus 2i, 5 plus 2i, twice. And then we FOIL. So 5 times 5, 25. 5 times 2i, 10i. 2i times 5, another 10i. And 2i times 2i, 4i squared. Again, combine like terms. 25 stays here. 10i plus 10i, 20i. And here's the I squared again, which I need to replace with negative 1. So this is negative 4. 25 minus 4, 21 plus 20i. Here's my answer for that one. Okay, so addition, subtraction, multiplication, and evaluation of these complex expressions is not that complicated. All you must remember is if you encounter I squared, you replace it with negative 1. And to evaluate, if there's a minus inside of the square root, that must be converted to square root of negative 1, which is an I. Okay, so in the next video, we'll take a look at multiplication, in division, that has two distinct procedures.